Okay, folks, we're going to go ahead and take a look at the solutions unit now. This is the beginning of this unit is mainly going to be a lot of vocabulary, and so I'm going to kind of brush through this vocabulary section rather quickly. You can get these words written down, and you can take your time studying these words. I will tell you that you definitely need to understand all of these definitions for your tests and for your quizzes and all that good stuff. But just make sure that you are getting these written down the way you need to. Okay. First, we're going to take a look at a little bit of review in terms of what mixtures are. This is a big one right here. Don't forget, a solution is a homogeneous mixture. A homogeneous mixture is a solution. Okay, we can use those two terms interchangeably. Don't forget also heterogeneous mixtures. We've got colloids, we've got suspensions. Okay, mainly this unit we're going to be focusing on solutions though. Okay, so let's take a look at a few different terms that we need to be aware of. First off, we have the term soluble. Okay, the term soluble just means that something is capable of dissolving. Okay, if it can dissolve, it's considered to be soluble. Okay, let's think about if I have sugar that I dissolve into water. Well, I still have sugar molecules. I'm just making them go from a big granule to a much, much tinier molecule, okay? So it's only a physical change. I didn't actually change the sugar itself. I just changed the way it looks. So dissolving or being soluble is actually just a physical change. A couple things we need to be aware of. The thing that does the dissolving, the thing that's present in the larger quantity is going to be the solvent. The thing that is going to be dissolved is actually called the solute. Okay, so for instance, with sugar and water, sugar is going to be the solute, water is going to be the solvent. Okay, there's a few questions here about can I have a gas dissolved in a liquid? The answer is yes. In terms of soda, that's something that we see all the time with soda, Dr. Pepper, all Coke, all that fun stuff. Okay, gas and gas, of course, we breathe that. We've had that every second that we've been alive. Okay, because air is a homogeneous mixture or a solution of nitrogen and oxygen and other gases that are present in our atmosphere. Okay, liquid and liquid, solid and solid, all of those things can also be capable of being solutions as well. So those are just some things to kind of keep in mind. A few more definitions here. If things are, well, first off, if things are soluble, they can be dissolved, right? Well, if things are insoluble, then of course they can't be dissolved. The terms miscible and immiscible are referring to the solubility of liquids only. Okay, if you have two miscible liquids, that means that you've got two liquids which can dissolve together. Okay, if you have two immiscible liquids, that would be something like water and oil. Okay, water and oil, they're both liquids, but they don't dissolve together. Okay, those are going to be two immiscible liquids. Okay, I'm going kind of fast on this because really, if you need to pause or whatever to write down some of these definitions, you can do that just by pressing pause. So I apologize if this feels like it's going too fast. Okay. Let's not forget also that density is what's going to determine what's going to float and what's going to sink when we're talking about immiscible liquids. Okay. So, for instance, oil is less dense than water, so oil is going to float on top of water. Okay. Next, we're going to get to our solubility rules. Okay. This is what I like to call our primary solubility rule. And that primary solubility rule is like dissolves like. Okay. And what that means is that if you have a polar covalent substance, oops, how about just polar covalent? It's going to dissolve into a polar covalent solvent. Okay, same thing with nonpolar. A nonpolar covalent solute will dissolve into a nonpolar covalent solvent. Okay, so when we do these, we need to remember how to draw our Lewis dot structures. Okay, so let's check this out. If I've got water and phosphorus tribromide, well, hopefully we know by now that water is polar. If we don't, we can draw Lewis dot structure. Okay, and I see from my Lewis dot structure that I have hydrogen, hydrogen, unshared pair, and unshared pair. So since not everything is the same, I know that water is polar. Okay, let's look at phosphorus tribromide. I've got phosphorus in the middle, I've got 3 bromines, and I've got an unshared pair on top. Okay, bromine, 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 unshared pair. Okay, so since it's not all the same all the way around, I know that this is also polar. Okay, polar solvent, polar solute, those will dissolve with each other. Okay, let's look at another one. Let's look at water and carbon tetrafluoride. Well, I know that water, once again, is polar because of our Lewis dot structure. Okay. Carbon tetrafluoride, however, when I draw its Lewis dot structure, I have carbon in the middle and 4 fluorines all the way around it. Well, around this one, I do have all the same. Okay, I've got fluorine, 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 which means that since it's all the same, it's going to be non-polar. This one was polar. So these two would be insoluble with each other because of the like dissolves like rule. And I need to erase. Oh, how about we just go to this? There we go. All right. Now, some things will also be able to dissolve in polar covalent solvents like water. Okay. And what I'm referring to here is ionic compounds. Okay. Some ionic compounds can dissolve in water. Okay. Some cannot. We have to follow our solubility rules in order to figure out what's going to dissolve and what's not going to dissolve. Okay. Here is our solubility rules right here. I know that all group 1 salts are soluble no matter what. So that means when I look at the periodic table, okay, and I see that I've got, here's group 1 right here, okay, lithium, sodium, potassium, so on and so forth, okay. All of these group 1s, if I have an ionic compound that is paired with one of those, it's going to be soluble no matter what, okay. Some of them have exceptions. Okay, for instance, all chlorides, bromides, and iodides are soluble, except silver, mercury, and lead are going to be our exceptions to that rule. Okay, so if you have silver chloride, even though all chlorides are soluble, silver is an exception to that rule. Okay, so silver chloride would be insoluble. Okay, probably the most important rule here is this guy right here. All other monatomic and polyatomic anions are insoluble except for group 1 and ammonium. That means that any of the other weird polyatomic ions like sulfite or nitrite or cyanide or permanganate or anything else that you can come up with is going to be insoluble. Okay, and that's a really super important rule. And I think that is going to, oh, we're almost done. We call water the universal solvent. Okay, the reason it's called the universal solvent is because it dissolves so many things. Okay, it dissolves polar covalent substances, and it also dissolves the ionic compounds which follow those solubility rules. Okay, so when we look at each one of these substances, each one of these follows a solubility rule from the previous page that you can check out. Okay, and so that's how we figure these out. For instance, CaF2 we know would be a solid or a precipitate because it is insoluble. Okay, and we know that because if I go back up here, I see that all fluoride salts are soluble except, and calcium is one of my exceptions to that rule. Okay, I come over here, calcium hydroxide. Well, I know that all hydroxides are insoluble except group 1, ammonium, barium, strontium, and calcium. Well, calcium's an exception to that insoluble rule, making calcium hydroxide soluble. Okay. Um, Here's a little summary chart of what I just talked about. If you have 2 covalent compounds, you have to use the like dissolves like rule to figure out if those are going to be soluble or not. If you have a nonpolar solvent and an ionic compound, it is always insoluble no matter what. Okay, you can never get salt to dissolve into vegetable oil. It's just not going to happen. Okay. Lastly, if you have a polar covalent solvent and an ionic solute, you have to check the solubility chart. And that's this guy right here. Okay, so make sure you know how to use this chart. Make sure you understand like dissolves like, and make sure that you know how to work with the definitions for this unit. Thanks, guys.